So in this video, we're going to talk about the idea of E1 reactions versus E2 reactions and what are the conditions that favor an E1 versus an E2, right? So you got to be able to differentiate whether you're dealing with an E1 or an E2 reaction. So we say an E1 reaction involves a slow step, which is formation of a carbon cation, then a fast step. And we say that the E2 reaction, in other words, is really concerted, right? So it all happens in one step. Now, the conditions that favor an E1 reaction versus an E2 is the idea that anytime I see a tertiary alkyl halide, it is more likely that an E1 reaction is going to occur on a tertiary alkyl halide versus a secondary alkyl halide. The base is also important, right? So in E1 reaction, we actually use weak bases, and these are stuff like water. Example would be of a weak base would be water. The opposite is true for an E2 reaction. It is more likely to occur on a secondary a secondary alkyl halide versus a tertiary alkyl halide. The base is also the opposite. So an E2 reaction, because it is a fast reaction, all occurs in one step, we expect the base to be strong. And these are your alkoxides. So these are any carbon chain with the oxygen that has a negative charge, and maybe a counter ion like sodium to balance the negative charge in the oxygen. Right, so strong base for an E2 reaction. Right, a special base that you guys will learn in organic chemistry is the idea of we have potassium terpetoxide, and this we say always gives you the Hoffman product. And we're going to look at an example, right? But that will always be your classical E2 reaction. So let's look at a couple examples and see if we could tell whether we're going to deal with an E1 reaction or an E2 reaction. So here's an example. And we're given as the reactant in this case, right? Now, if you look, we're dealing with a secondary alkyl halide, which has only one hydrogen on the carbon of interest. Our nucleophile is really strong. So, in other words, this can actually go through an SN2 reaction, right? But for these, because it's kind of in between, your professor usually will tell you, okay, well, assume elimination or assume substitution is minor here. So, in other words, if we assume that substitution is minor, then we're really dealing with now you got to differentiate. Oh, wait, am I dealing with an E1 versus an E2 reaction? Well, the fact that the base is strong because we're not doing substitution and I'm on a secondary alkyl halide, this is likely to go through an E2 reaction. And so the base essentially the reaction is going to occur in one step, takes off the hydrogen adjacent to the alkyl halide, forms a double bond, and dispel the alkyl halide in one step. And so if we assume that elimination is minor here, what we're really looking at is the product like this. And this will be the Zaitsev product. The Hoffman product, again, would have the double bond around here. But again, that's not, we're dealing with the major product here. So that'll be cause for an E1 reaction. So we said, an E2 reaction. Right? Secondary alkyl halide, the base is really strong. So that'll be an E2 reaction. How about this one? Can you tell whether this will be an E1 or an E2 reaction? Right? And we put this in water. Well, I take a look at the base. Water is really weak. Right? So we have a weak base, and I'm on a tertiary alkyl halide. So if I'm on a tertiary alkyl halide, that means that the carbon chain is not really open to attack, and the base is really weak. So I'm looking at an classical E1 reaction. So this would be your classical E1 reaction. Now again, assuming that elimination is assuming that substitution is minor here. So if we assume that substitution is minor here, then the bromine essentially leaves. I form a carbocation. And then water comes in, attacks the hydrogen and form a double bond. And so essentially my major product would be something like this. So again, a tertiary alkyl halide, a weak base, and again, we're saying for all of these, assume that substitution is minor. How about this one? This base is potassium tert-butoxide, and it will always give you the Hofmann product. So because we have two adjacent carbons containing the alkyl halide, that's from the alkyl halide, it will give you the double bond at the end, right? So out here, as opposed to in the middle, where it would be your Zaystat product. So this will always give you a classical E2 reaction, all occurring in one step. It will take the hydrogen and essentially form a double bond, displace the bromine, and so essentially my product would be this. So that would be a major product from potassium tert-butoxide. This is your classical E2 reaction. What about this one? Or maybe I should let me write a different structure. So what about this one? Right? And you put this in water. Is this an E1 or an E2 reaction? Well, the base is really weak, water, right? There's no charge in water, so the water is a weak base. And I'm dealing with a tertiary alkyl halide, so the base is not weak. The base is weak, and the carbon is really not open to attack. In other words, I'm dealing with a tertiary alkyl halide. So this is your classical slow reaction. The reaction will proceed slowly, or in two steps, or this will be your classical E1 reaction. Right? So the first thing that occurs, bromine leaves, you form a carbocation. Because the bromine leaves, you form a carbocation. Then essentially, let me move this over, but essentially another molecule of water comes in and attacks the hydrogen adjacent to the carbon. So in this case, I have two hydrogens here, right? Come in, attack, forms a double bond, and then that will give you your major product in this case, which would be this. So that would be your product. So again, we did the difference between an E1 and an E2 reaction. Again, E1 reaction usually occurring on a tertiary alkyl halide, and your base is really weak. In E1, an E2 reaction all occurs in one step. We spoke about the special case of potassium tert-butoxide, but also if your base is really strong, like an alkoxide, and you're on a secondary alkyl halide, okay, that can really go substitution. Well, your teacher usually, because it's in the gray area, it's actually a mixture of both substitution or an SN2 reaction and an E2 reaction. But again, if we're assuming that substitution is minor, then we're really looking at an E2 reaction.